A use case diagram is like a picture book that shows who can do what with a system. Imagine a playground. The children actors can swing, slide, or play tag use cases. The diagram helps a team understand the stories the software must support from a very high level, without getting lost in code details. It is useful early in a project to talk with customers, decide the project's size, and decide which parts of the system are in scope, just as you decide which games are allowed in the playground and which are not. Actors are the people, other systems, or devices that interact with the software. Think of a house. The family members are actors outside the house. The door is the boundary that lets them in, and inside the house are the rooms they can use. In a use case diagram, we draw a stick figure for a human actor, a rectangle for a system actor like a payment gateway, and we label them primary if they start the interaction or secondary if they help. The boundary is drawn as a big box called the system boundary, like the walls of the house, and everything inside is what the software does for the actors. Building a use case model is done in 3 steps. Identification: list all the things users might want to do. Talk to real users, watch them, and write down every verb phrase, for example, login, order pizza. Refinement: take each rough idea and give it more detail. Add alternate flows: what if the credit card is declined? Include extensions, extra steps, and group similar cases into higher level ones. Documentation: write a concise description for each use case, usually in a template. Goal, primary actor, precondition, main success scenario, extensions, post-condition. Then draw the diagram with actors, the system box, and ovals for each use case, linking actors to the ovals with lines. This is like turning a list of playground games into a clear map with signs and rules. A class diagram is a blueprint of the software's building blocks. Each class is drawn as a rectangle split into 3 compartments. Top colon, the class name like car. Middle colon, attributes such as color, speed. Think of them as the data the object holds, like a car's paint and its odometer reading. Bottom colon, operations like accelerate or brake. These are the actions the object can perform. The syntax is simple: colon, visibility plus public minus private hash protected, followed by name type, and parameters plus accelerate amount int colon void. This helps developers see what each object knows and can do, much like a recipe card listing ingredients, attributes, and steps operations. Explanation: relationships tell how classes are connected. Association is a simple friendship line. For example, a teacher class is associated with a student class. A teacher teaches many students. It can have a role name and multiplicity 1 star 0 to 1. Aggregation is a has-a but weak link, like a team aggregates many player objects. If the team disappears, the players still exist. Composition is a strong part of link, like a house composed of room objects. If the house is destroyed, the rooms go away too. Mathematically, composition is a special case of aggregation with a cardinality of 1 and lifetime dependency. Inheritance, also called generalization, is a link. A bird class can be a parent of sparrow and eagle. The child inherits attributes and operations from the parent. Dependency is a dashed arrow showing temporary use, like a report generator depends on a database only while creating a report. It is similar to uses in math. A arrow B means a needs be for a short time. Turning use case stories into classes is like turning a storybook into characters and props. First, pick out all the nouns. They often become candidate classes. For example, in the buy book use case, nouns are customer, book, payment. Next, look at the verbs. They become operations: search, add to cart, pay. Assign responsibilities. Decide which class should own each operation based on who has the information needed. The customer knows the address, so it should have enter address. Then draw collaborations. Show which classes call which other classes to fulfill a use case. A sequence diagram could be used, but in a class diagram, you just add associations or dependencies to indicate the collaboration. This mapping ensures the design directly supports the required behavior, much like assigning each actor a role in a play that matches the script. To keep the 2 diagrams in sync, apply validation rules. Every actor use case interaction should be represented by at least one class that provides the needed operation. No class should be orphaned unless it is a utility class on purpose. Names must match exactly. For example, a use case called register should map to an operation named register. In a class, not sign up unless you create an alias. Multiplicities in associations must not contradict real-world constraints expressed in the use case. For example, a bank account can have only one owner, not many. Inheritance hierarchies must be acyclic. You cannot have a class that is its own grandparent. No loops. Consistency checks can be automated with tools that compare model elements. Think of it as a spell checker for diagrams. Many tools can draw UML. Free options like Draw.io, Lucidchart, and Plant UML. Professional suites like Enterprise Architect, Visual Paradigm, or Magic Draw. Keep each diagram focused. One use case diagram per major functional area, one class diagram per subsystem. Use clear naming conventions. Pascal case for classes, camel case for attributes, verbs for operations. Limit the number of elements per diagram, 15 to 20, to avoid clutter, like not putting every toy in one box. Store diagrams in version-controlled files, for example .uml or .xml, so changes can be tracked. Regularly review diagrams with the whole team, updating them as requirements evolve. This makes the models a living map, not a static picture, and helps everyone stay on the same page throughout development.